Here we go. We have a question alien dictionary. We have given a sorted dictionary of an alien language having n words. So we have a dictionary and there are 5 words in this test case and k starting alphabet of standard dictionary means k is equal to 4. So k alphabets are there. We have to find the order of characters in the alien language. Many orders may be possible for a particular test case. Thus, you may return any valid order and output will be 1. If the order of string returned by function is correct, else 0, denoting incorrect string returned. So, we just have to return the valid order. So, we have this test case. So, in this first we have BAA. So there are 5 words and BDAC are 4 characters. So the order of character is BDAC. So first we have BAA. Next we have this word ABCD, which means B. This B is occurring before A. So first we have B, then we have A. This configuration is valid. So if we have this word and this word, we have to compare A and A is equal. Next we have B and B, it is also equal. C and C, it is also equal. Then we have D and A, which means D occurs before A. So D occurs before A. If we have this string, which means A occurs before C, A occurs before C. Next we have this word C and C equal, A and A equal, B and D is not equal, which means B occurs before D. So this here order of character is this. Note that words are sorted and in the given language BAA comes before ABCD. Therefore B is before A in output. Similarly, we can find other orders if they are possible. So this question is a very popular graph question. So let's build the approach. So we have this test case. If we have only single word, that's not an issue. We can return anything. Before this, let me create something. We know there are 4 words, but we don't know what are those. There are 4 characters, but we don't know what are those characters. So first we iterate in each and every word and find the unique characters. First we have B, so one character is B. Then we have A, C. Then we have C. Then we have D. So D, A, B, C, A, this character. So there are these characters. Let me tell you, this is a map. So D, first we have D, and the value is something we have to find. So let's check out. First we have this. If there is only one word, that's not an issue. So we start from the second word, this word. So we find the character here and here. So we check. Is it equal? No, it is not equal. So B occurs before A. So there's an edge from B to A. So after B there are some characters. So there is only A here. We have tackled this. Next we have this word and this word. So after we find a non-similar character, a different character, uh, we will add into a map and just break. Next we have this character, this word. So we check with previous word. Is it equal? Yes, it is equal. Is it equal? Yes, it is equal. Is it equal? Yes, it is. Is it equal? No, it is not equal. Means D occurs before A. So D occurs before A. After D, there's a character A. Let's go to next word. So here the length is different, so we will iterate only for three words. So we find the minimum length between previous word and current word and iterate till minimum length. So here we will iterate only for three times. Here the character is not equal, means A occurs before C. A occurs before C. So after A we have character C. After A we have character C. Let's go to next word. We have C and C, it is equal. A and A, it is equal. Next we have D and B, means this B, this B occurs before D. This B occurs before D. So after B, there's a character D. After B, there's a character D. So now we have created our graph. This is a graph question. Here it is character, and here we have list of characters. So we have a map. Key is simple character and value is list of characters. So now we have to iterate and we have to find the order. Before this, there's a prerequisite. So I hope you know what is topological sort and you are familiar with this algorithm. I will apply topological sort using DFS. So we have some characters B, A, C, D. So as you know, this is not sorted because we have hash map. So this is not sorted. So we will start from any character. Let's start from B. So first B, and we will do topological sort. So in topological sort, we have a set which tracks which node is visited and we have a stack. So starting from B, we go to A. Starting from B, we go to A. So after A, we have a character C. We go to A. Then after A, we go to C. And after C, there's a nothing. There's nothing. So we first push the last character. Next, we go the previous node, which is A. It is done. So from B onwards, we have traversed A. Now it's time for D. We will go to D. So we have a node D. Next we have A, but A is already marked, C is already marked. So we cannot go to A. So we have only D, and we have traversed all its neighbors. So we have B. So from B we have traversed A. From B we have traversed D. It's time to add B. Now, if I pop out B, so I will add B. Next, the element is D, so I will add D. Next, I will add A. Next, I will add C. So, this is the order. If you check this, B, uh, B is B have to be before A and C and D also. So, B is before D A C and D have to be before A and C. D is before A and C and next C. So A have to be before C. So this order is correct. So that's how we will solve this. First, what we have to do? This step one. Step one is to create a graph. In this case, the graph is a map. So first we have to create a map. So before this, we first have to add all characters. Next we iterate in these words and we check which word is different, so we can create an edge. So find different character and add edge here. After doing this, we have to apply topological sort. That's all. Let's code this. We have a map character and its value is list of characters. So first we iterate in the dictionary. We take this word, and in this word we have to iterate on every single character. So I am converting this word into a character array and putting a character and its corresponding a list. Next we iterate from word number 1. So we can check with the previous word. So this is the loop for checking every single character, and we have to find the minimum length between this word and the previous word. So this is the previous word length and this is the current word length. We have to find the minimum. So if the jth word is not equal between previous and current word, so we have to get the previous character get the previous character and add the current character. So it specifies, suppose this and this, so b, after b there's a. So that's how we are creating our graph. So if we find any different character, we will just break out. Next we have to apply topological sort. So for this we require a set and a stack. Iterate in every character. Map.keyset will give me all the keys. So this is the word, this is the character here. So we have to iterate in this only if it is not visited. So I am applying topological sort, passing my graph, stack, set, and the node means character. So this is the function and I am getting all this. First we have to visit this and traverse its neighbors. So this is the neighbor. We know the neighbor is available in the graph. If the neighbor is not visited, we go to its neighbor. So I am passing neighbor here. And after this, we have to add into a stack. I highly believe you already familiar with the topological sort. That's why I am not taking much time here. So after doing this, we have to add. So we have to return an order. So this is the string. So while stack is not empty, we will take out the element and after the append after the answer string. So just return your answer and let's submit this. The code is given in the description box. In between, let's talk about time and space complexity. So our time complexities, we have to iterate on every single word and every single character. So this is the n means every single word. This is the word length and this means the maximum length. So we have this and after this we have k. K means the unique characters. So we are iterating every single character and after this we are iterating on each character. So that's it. And then we have this also iterates on every single character. So we have meet the expected time complexity. Let's talk about space complexity. So in space complexity it is order of k. So we are maintaining a map. So in map this the first key, this is the key and its length is at max 26. So we can say space complexity is order of k, which is the unique characters. And that's all we have visited and set. It also take of k space. So let me connect with my internet and let's submit this again. So the test case is processing and we have successfully solved this question. If you have any doubt, feel free to ask in the comment section. If you find this video informative, please like and subscribe, and I will see you soon.